times 2090 joules is equal to 52.25 joules. And we just copied the remaining negative 80. So next is we're going to multiply 52.25 joules times negative 80. So we have here the Q loss is equal to 4,180 joules. Next is the Q gain. We have the formula here. The Q gain is equal to mass times specific heat times change of temperature. And we put letter E as the coffee. Then we put it here, the 4,180 joule, which is we get here from the Q loss. And it is equal to mass of coffee times specific temperature of the coffee and times 2 the change in temperature of the coffee. So next is we're going to write here the 4,180 joules over the 0.05 kilograms, which is the mass, times the change in temperature, the 10 degrees Celsius. Then, as we have multiplied it, we will have 0.5 kilogram degrees Celsius, and we just copied here the 4,180 joules. Then, next is here, the 0.05 kilograms of the mass times the specific heat times the change of the temperature. So we will going to cancel here the mass and the change of temperature, and the remaining is the specific heat. So we just copied it here. So we have only specific heat. So we're going to divide the 4,180 joules, divide 0.5 kilogram degrees Celsius, and we have here the answer. It's 8,360 joules per kilogram degrees Celsius. So that's all in the problem 2. Now our last problem is 1,035 grams of aluminum spoon with 910 joules per kilogram degrees Celsius at 240 degrees is placed in a hot water. How much amount of hot water is required of mass at 23.0 degrees Celsius? If the final temperature of the system is to be 35.2 degrees Celsius, first we're going to write the given. So we have the aluminum and we put A as acronym. So the mass is 1,035 grams and we converted it into kilograms, and we have here the 1.035 kilograms, and the specific heat is 910 joules per kilograms degrees Celsius, and the initial temperature is 248 degrees Celsius and the final temperature is 35.2 degrees Celsius, and we will going to minus the final temperature and the initial temperature in order to get the change of temperature. So 35.2 degrees Celsius minus 248 degrees Celsius is equal to negative 212.8 degrees Celsius. So next is the water. So we put the initial W. So the mass is missing. So we're going to put question mark. So next is the initial temperature. We have 23 degrees Celsius and the specific heat is 4,190 joules per kilogram degrees Celsius, and the final temperature is 35.2 degrees Celsius. And we're going to minus the final temperature degrees to the initial temperature degrees to get the change in temperature. So 35.2 degrees Celsius minus 23 degrees Celsius is equal to 12.2 degrees Celsius. So now let's proceed to the solution. So we have here the formula of kilos is equal to mass times specific heat times the change in temperature. And we put letter E here as the aluminum. So next, we're going to put the given. So the mass is 1.035 kilogram. And the specific is 910 joules per kilogram degree Celsius. And the change of temperature is negative 212.8 degrees Celsius. So first, we're going to cancel out the kilograms. This is the specific heat. Cancel. So next is we're going to times the 1.035 times 910 joules is equal to 941.85 joules. And we just copied the negative 12 here, 0.8. Then we're going to multiply it. So 941.85 joules times negative 212.8 is equal to 200,425.68 joules. So next, we're going to solve the Q gain. So we have the formula. So Q gain is equal to mass times specific heat times change in temperature. And we put W to determine as a water. So we're going to write here the 200,425.68 joules, which we have it here. And then it is equal to mass times the specific heat of 4,190 joule per kilogram degree Celsius. And then times to the change in temperature is 12.2 degrees Celsius. So next, so we're going to write here the mass is equal to 200,425.68 joules over 4,190 joules per kilogram degree Celsius times 12.20 degrees Celsius. So first, we're going to cancel out the joules. Next is the specific heat. So the remaining only is the kilograms. So we're going to multiply the 4,190 kilograms times 12.20. So the answer is 5118.0 kilograms. And we just copied here the 200,425.68. So we're going to divide it. So 200,425.68 divide 51,118.0 kilogram is equal to mass of 3.92 kilograms. So that's all. Thank you.